Before I go on and talk about the formula for calculating the area of a sector, there's just one more point I wanted to make about this formula, and I guess it's the case with all formulas. While the subject of this formula was L, the length, this formula can be used to calculate either r or theta as well. Now, in order for us to be able to find r, both L and theta would need to be given, and we would solve for r. Likewise, we could be required to find theta, and again, L and r would need to be given, and theta then would be calculated in terms of radians. So one formula can be used to calculate any one of the three variables contained within that formula. So just be aware of that. There's not an example in the explanation there that actually covered these concepts. However, I'm sure you've come across those sorts of questions before with other formulas, and you could see how it could work here. Okay, let's go on to the formula for calculating the area of a sector. It is simply a half r squared theta, and again we have an understanding that r is the length of the radius of the circle and theta is the angle subtended at the centre by this sector, and that angle must be measured in terms of radians. Let's have a look at this example. It's the area of the sector of the circle that is subtended by this angle at the centre is 6 pi meters squared. So the area is actually 6 pi meters squared. Find the radius. Let me write down this information. So the area, given that the area of the sector is 6 pi. Now, hopefully we're making a connection. Area of a sector is a half r squared theta. We know that theta is equal to pi on 3, and it's given in radians, so that's all good. And the question wants us to find r. Now, this is a good example of what I was just explaining about the previous formula, in that, yes, we will take this formula, a is equal to a half r squared theta. We don't have a formula that stands alone with r as the subject, but we can use the formula where a is the subject, r appears in the formula, substitute into that formula and solve for r. So that's what we're going to do. Area is 6 pi, theta is pi on 3, area we know is a half r squared theta, and we're finding r. Use the formula, substitute for a, finding r, substitute for theta, do some simplifying, remove the denominator, 2 3s are 6, multiply this side by 6, this side by 6. We've still got r squared pi, divide both sides by pi, we get r squared is 36. We don't need to consider the negative aspect of taking the square root because it doesn't make any sense to have a negative radius. So we've got that the radius is equal to 6 meters are the units in this case.